Hello everyone, welcome to today's flash drill discussion session with me, Shreyas, your master teacher for physics at Vedantu. And you are in the channel We Enthuse, where we are going to prepare you for the JEE Mains, JEE Advanced, BITSAT, CETs, you name it. Alright, so welcome aboard guys. And in this flash series, we have so many different things like the flash extracts, the flash sessions, the flash motivations. Also you have the flash drills, which are nothing but the assignments, the daily practice problems that you get, and we provide you the proper video discussion sessions, yes, where we explain you the proper way of solving it. Was there any trick? Was there any catch? Is there some additional formula or some concept that you need? So that's why it's very important that you attend all these drill discussion sessions, be it in 11th, be it in 12th, be it a dropper, doesn't matter. Okay, so this is me guys, Shreyas, and you can also follow me on my Instagram account, Shreyas_Vedantu, where I keep posting regularly about different aspects about my, not just my personal life, but also some things on science, some things which are very creative, and some really cool experiments. So do not forget to follow me out there as well. And today in the evening, we are going to start with Newton's laws. So this is your schedule for this week, in case you're not aware of it. Yesterday we had just completed integration. I hope you remember that, and that's what we are discussing today, the drills, the daily practice problems. All right. Okay. So this week is completely on dynamics, Newton's laws and all that. And in case you are new, do not forget to subscribe, and also please like and share it with your friends guys, because your likes are the ones which are going to give us energy for conducting all these sessions. Remember, there are no fees for this channel. It's all free, but the only cost is your like and your support and your love. All right. Okay. So let's begin with our session guys. So the velocity of a particle is given by 4t plus 2. All right. And t is in seconds. Sketch the velocity versus time graph. You have to also find the position using integration, and you have to also find the displacement from 2 seconds to 6 seconds. So let's start solving it. Now let's do the graph part first, because that is very easy. So if you look at this velocity graph or the equation, v is nothing but 4t plus 2, you can see that it is resembling your straight line equation. Recollect your straight line equation. It was of the form y is equal to mx plus c. This is very much similar to that, and m over here is your steepness, or you can call it the slope. C over here is nothing but your y intercept. Where does it hit the y-axis? So that's all that is needed, and then you can immediately draw the graph. So let's start drawing it. You have to draw the graph of velocity versus time, right? So this is my velocity, this is my time. Let's say this is 0. The y-intercept is 2. You can see that very clearly. So it must be somewhere over here, let's say. And the slope m is 4, which is positive, correct? And 4 is quite a decent number, right? It's positive, so it should be up like that. If this was minus 4, it will be down like this. Negative slopes are down like this. If this was 0, then it would be flat. It would be parallel to the time axis. And higher this number, it will go more and more steep. Remember that. So this 4 will make it go up like this. So this is the graph. It's a straight line graph starting from 2, and you can see 2 is also the initial velocity of that particle. All right. So that's the graph. This was easy. I hope you have understood it. I'm just going to erase it quickly because this was the easier one. Let's go to the harder part of this problem. Now you have to find the position and then the displacement. Okay. Now if you recollect from yesterday's session, we have seen that if I know the velocity, I can find the position by integrating it. Remember, derivative of x was v, so integration of v will be x. Recollect this. So I can clearly say x is nothing but integration of v dt. Okay, so that's what it is. Now you might be wondering, should I use definite or indefinite? Well, it doesn't really matter. You will end up with the same answer. You choose whatever way you want, right? So let's just do it the indefinite way, right? So you will always have a constant of integration. There will be no limits. you remember, you will always get the same answer no matter how you do it. And in previous session I have told you how to do it either way: definite, that is with limits, or indefinite, that is with constant of integration. You get the same answer. So in case you are very new to this session, do not forget to watch the previous session where I have discussed both the methods. Okay, so over here, what is this velocity? Well, it is nothing but 4t plus 2 and dt. Okay, so recollect the rules of integration. I can split up the terms if there is plus or minus, and any constant that comes can be taken outside the integration. Do not forget that. So it will become 4 integration of t dt plus, even this 2 is a constant, and I'll just have dt inside over here. Now, what is the integration of t? Now you have to just use the formula, guys. X raised to n dx integration is x raised to n plus 1 upon n plus 1 plus that c. So over here the value of n is 1. Instead of x you have t. That's the only difference. So this will become t raised to 1 plus 1 is 2 divided by 1 plus 1 again is 2 plus 2. You might be wondering, oh, there is nothing to integrate, so is the answer 0 or is it something else? Guys, you can always imagine as if over here, right, you have t raised to 0. Just think as if t raised to 0 is over here, because 1 multiplied by anything is just the same number. So if it was t raised to 0, what will happen if you use this formula? Think about it. It will be t raised to 0 plus 1, which is nothing but t raised to 1, correct? So it will become t raised to 1 and divided by 0 plus 1 is just 1. And of course, because we are doing it by the indefinite way, there should be a constant out there, and hence this will become 4 by 2 is 2. So it will become 2t square plus 2t plus c. That is the answer for x. But it's not complete yet because c is unknown. So can I do something about it? The velocity of a particle is given where t is in seconds. Sketch the graph using integration. Well, I don't think by the given information I can just find c. I hope you understand that. This c will have to remain as it is. I do not know that. So this is the final answer for the position. You cannot do anything more about it. Understand? Okay. So this is the final answer. If some additional information was given that, you know, at this much time the position is this much, then you could have done something, but right now I cannot do anything about it. I hope this is very clear. Now, after this, the next part comes where we have to find the displacement from 2 seconds to 6 seconds. Is it possible to find the displacement even without finding c? Yes. I'll tell you how. It's very simple. See, just find what is the position at 2 seconds, right? What is the position at 2 seconds? That means substitute the value of time as 2 in this particular equation. So what will you get? Think about it. 2 into 2 square, all right, plus 2 into 2, okay, plus some constant. I do not know what it is. Then again substitute the value of time as 6 and find the new position, right? So 2 into 6 square plus 2 into 6 plus c. Now think about it, guys. What you can do? You just have to find the displacement, right? So what is displacement? Do not forget, displacement is final position minus initial position. This was final and this was initial position. So between 2 to 6, that's how you can find the displacement. So that's why this c won't matter when you find the displacement. It will get cancelled out. So what is x6? x6 is this much. So 2 into 6 square plus 2 into 6. Do not forget about this c. It will get cancelled when you subtract it. So minus 2 into 2 square plus 2 into 2. So just do this math. This minus can be taken common because you're subtracting that. That's it. Just substitute, just solve, you'll get the answer. 6 square, 36 plus 6, 42, and over here 4 plus 6. So that means 42 minus 6. So I think you should get this as 72 meters. Just check this out. you should get this as 72 meters. So the interesting part about this problem, guys, was that even though you do not know the value of c in this function, you could find the change in x, because the moment you find the change in x, this constant gets cancelled out. So that was the interesting part about this problem. Okay, so let's go ahead. I hope you guys have understood it, and anytime you feel like taking a screenshot, please go ahead and take a screenshot. All right, so let's go ahead now. 72 meters was the answer for this question, just like I told you. Okay, now find the velocity of the particle starting from rest, okay, as a function of time if the acceleration is given to you, and also find the average and the instantaneous acceleration. Okay, a lot of things to be found, so let's start one by one. Okay, here we go. Now acceleration is given and we have to find the velocity. Okay, now recollect, derivative of velocity was acceleration, so integration of acceleration will be velocity, correct? That's what we have seen. So hence I can say velocity is integration of acceleration with time. Now, do you want to go the definite way, indefinite way? It's up to you. It's completely your choice. Remember that. So I'm just going to go ahead with the indefinite way. It doesn't make any difference. I hope you remember that and you also understand that. So acceleration is 4t cube plus t square dt. So obviously use the rules of integration of separating the terms and taking the constants outside. So it will be 4 integral t cube plus, okay, 1 second, 4 integral t cube dt plus integral t square dt. Okay, now what is the integration of t cube? Use the formula x raised to n. Integration is x raised to n plus 1 upon n plus 1. Use that. So it will become t raised to 3 plus 1 divided by 3 plus 1, which is 4, plus t square's integration, guys, is nothing but, think about it, t raised to 2 plus 1, which is t cube, divided by 2 plus 1, which is again 3, and obviously the constant of integration out here. This 4 gets cancelled, and hence I'll get velocity is equal to t raised to 4 plus t cube by 3 plus c. Oh, I want to find the c, but I can use some information. Here it says that it's starting from rest. That means when time was 0, velocity was 0. I can use this information. So use this information and see what do you get. If you use this information, what do you get? Think about it. Velocity is 0 when time was 0. Just substitute time as 0, v as 0. You will get constant of integration as 0. That's how you find constant of integration, using some other information which should be given in the problem, else you cannot find it. Remember that. Okay, great. Now I have found out the constant of integration. So therefore my velocity will be t raised to 4 plus t cube by 3. So that is my function which was needed for the first part of the question. Great. So that first part is done. Find the average acceleration and instantaneous acceleration. Well, instantaneous acceleration is quite easy. So if I had to find instantaneous acceleration, I will just say instantaneous acceleration is, okay, acceleration is already given, guys. So acceleration at 3 seconds will be 4 into 3 square plus, oh sorry, it was t cube, my bad. It was 3 cube plus 3 square. That's it. So 3 cube, guys, think about it. 3 square is 9, 3 cube is 27. 27 into 4 is 108. 108 plus 3 square was 9. So I think it should be 117 meters per second square. That's what you will get. Now, once you have got the acceleration at 3 seconds, that job is also done. The only thing is average acceleration. Now, you might think, oh, how do I find the average acceleration and all that? Guys, go by the basics, go by the definition. What was the definition of average acceleration? The average acceleration is nothing but final velocity minus initial velocity divided by the time. Just use this formula. So, that's it. That means, what do you need to do? What is the final velocity? Velocity at 3 seconds minus velocity at 0 seconds. Why 0 seconds? Because he starts from rest and you have to find the average till 3 seconds. So till 3 seconds, that is final, and 0 seconds will be initial. Upon the time taken is 3. That's it. So just substitute everything. In this equation, we have already found the velocity equation. Just substitute time as 3. So you will get, think about it, 3 raised to 4 plus 3 cube divided by 3 minus, substitute 0 raised to 4 plus 0 cube by 3 divided by 3. Okay, now you can do this orally as well. Okay, this term will be 0. 3 cube by 3 will be 3 square. And this is 3 raised to 4. So 3 raised to 4, guys. Come on, think about it. I think it should be 81. And this is 3 square, right? Because 1 3 gets cancelled. Okay, so it was 3 cube by 3. Okay, so 81 plus 9 is 90. 90 by 3, guys, it is 30. So I think the average acceleration should be 30 meters per second square. So you can see the instantaneous and the average values are quite different. And we did not use any graphical techniques. We did not find the area or anything. We just use proper formulas to get the answer. Let me tell you, this is how simple it is. If you know the formulas, the definitions, the concepts, that's it. I have used concepts, nothing more, nothing less. Whatever I have been teaching you, that's all that I have used. Okay, I hope you guys have understood this. Let's go ahead. Okay, so next question is, find the position of the particle if acceleration is given. Assume initially velocity and position or the coordinates are 0. Okay, so let's think, what do we do? Now since we have to find x and a is given, we cannot do it directly. From acceleration, first find velocity, and from velocity find position, guys. Yes. And how do you do that? Integration. Why? Because whenever you have to go from acceleration to velocity, remember you have to use integration, and whenever you have to again go from velocity to position, again you have to use integration, right? Only the reverse way requires derivatives, that is from position to velocity to acceleration. So let's use this and see what do we get. So acceleration is given, so let's do this. Velocity will be integral of acceleration, which is 4t cube plus 3t square plus 2t dt. I've just used the acceleration value over here, nothing else. So just split up the terms, guys. So integral 4t cube plus 3 integral t square. Okay, I just have to put that dt also. Okay, so plus 3 t square dt plus 2 t dt. Now just integrate this and you will see what is the answer. Use x raised to n formula. This will become t raised to 4 by 4 plus 3. T square's integral will be t cube by 3, and t's integral, guys, will be t square by 2, of course, and plus one constant which I do not know yet. I'll put it as the first constant because I'll have to integrate it twice, so I might get another constant as well. All these numbers get cancelled, so it will become t raised to 4 plus t cube plus t square plus c1. That's what you get. But it is given at time 0, the velocity is 0. So use that. So using, right, velocity is 0, at time is 0, what will you get? Very obvious, constant is 0. So therefore, the velocity, guys, will be t raised to 4 plus t cube plus t square. So that's velocity. But we are not done yet. Do not be happy. Do not celebrate yet. We need to find what is the, yes, we need to find, guys, what is the position. So use this and integrate to find position. So recollect, x is integral velocity, this big term, which is t raised to 4 plus t cube plus t square dt. So that is what we need to integrate to find position. So let's do that, guys. Come on. Okay, do not lose track. Okay, let's do this. So each term separately. What is integration of t raised to 4? If you want, I can write one step. I don't mind it. but it is just very easy, which is just I've used the rules of integration of addition and subtraction. Okay, so think about it. What is t raised to 4's integration? It is t raised to 4 plus 1, which is t raised to 5, divided by 4 plus 1, which is again 5. And same thing goes over here. So it is t raised to 4 by 4, and t square's integration will be t cube by 3. And do not forget another constant, but this time let me call it C2. Let me just call it C2. We have used the alphabet C1 over here, that's why. Okay, is something else given to me? Yes, at time 0, x is 0. Use that. So that means when time is 0, x is 0. So most of these terms just go away. So that clearly tells me C2 is 0, guys. Therefore, what is the value of x? It is t raised to 5 divided by 5 plus t raised to 4 divided by 4 plus t cube divided by 3. And that should be your final answer. That's it. It's just integrating twice. Nothing great about it. It's just a process which you need to follow, and you should remember the formulas of integration, and also you should know whose integration gives you what. If you remember that, that's it. Okay, and do not forget, guys, I have given you the summary of the entire chapter in case you forget, right? Whose integration gives you what. There is one summary of the entire chapter which I'm going to give you, or probably it's already shared in one of the links. Just keep a track of those links, and also the Telegram group. It has the summary of the entire chapter. Okay, great. So that was the answer. T raised to 5 by 5 plus t raised to 4 by 4 plus t cube by 3. Next question. What is the velocity when the position is 2 meters? If acceleration is a function of x, assume the velocity of the particle is 0 when x is 0. Now this is very special problem, because here acceleration is not a function of time but a function of x. So you will be like, what do I do? Well, let's see what do we do. It's a very tricky problem. So let's see whether you follow this. Acceleration is 4x cube. Now you'll have to use some mathematical manipulations to get to the final answer, and let's see how. Remember, what is acceleration? Acceleration is derivative of velocity with respect to time, right? Okay. Now here is the problem. I have 3 variables: velocity, time, and x. I cannot solve this. Whenever I have integration problems, I need to have only 2 variables. One variable on one side and the second variable on the other side. The moment I have 3 variables, it's not a solvable problem. So somehow use some logic, some out of the box creative thinking, some manipulation, and get it to 2 variables. Only then it is integrable, and that is called as integrable form. All right, so let's get it in that beautiful form that we want to. So here is the trick, and the trick is chain rule. So what was chain rule? In case you do not remember or you have not studied it, chain rule is nothing but just multiplying and dividing it by the same number, because when you multiply and divide by the same number, it just cancels out. It's almost like that. Okay, so what do I multiply and divide? Well, that has to be cleverly thought about, and with practice you will get it. Now since I have been practicing obviously a lot of problems, so I know what to do over here, but do not worry, you will get there. All right, so the trick over here is divided by dx and multiplied by dx again. Anyways, it gets cancelled, and do not forget to maintain the equality. I need that dt as well over here. Now this will become 4x cube, of course. You might be like, okay, what did we achieve? Well, this is what we achieved. This is dv by dx. Now do not forget, this dx by dt is actually velocity. Yes, so that's why cleverly I multiplied and divided it by dx. So this was basically a part of something called as the chain rule. So chain rule is just nothing but multiplying and dividing it by the same thing, right? That's what it looks like. And dx by dt is nothing but velocity, and this is nothing but 4x cube, of course. Now you'll be like, okay, so what now? Well, just move this dx guy over there. Yes, just move it over there. So it will become v, and dv will come over here, is equal to 4x cube and dx. So just move them over here, 4x cube and dx. Now what do we do? Well, now you integrate, guys. Yes, You just integrate. Do I need to put limits? Well, you can, but we can also go the indefinite way. So just integrate it and let's see what do we get. So V dv's integral, use the formula x raised to n, integration is x raised to n plus 1 divided by n plus 1. So it is V raised to 1, so it will become V raised to 1 plus 1, which is 2, divided by 2 of course, is equal to 4x cube. It will become 4 x raised to 4 divided by 4 plus the constant. Now you might be like, sir, won't there be two constants here? Guys, just imagine if there is one constant here and one constant here, why don't you combine it into one constant, right? So no point putting C1 and C2 there, just merge it into one single constant called as C, all right? So use this trick every time. Do not put two constants. Okay, let's simplify this. So it will become V square by 2 is equal to x raised to 4 plus C. Let's use the given information. The velocity of the particle is 0 when x is 0. So use this. Velocity is 0 when x is 0. Oh, again, luckily for us, C is 0. So that means I feel I have got the velocity formula. So V square by 2 is x raised to 4. That's it. And what do we need to find? Find the velocity when x is 2. Okay. So when x is 2, V square by 2 will be 2 raised to 4, of course, right? I just substituted the value as x is equal to 2. So therefore, it will become, think about it, I take square roots on both sides. It will become V by root 2 is equal to 2 raised to 4's root is 2 square. That's it. So that's why this will become V is equal to, by the way, 2 square is nothing but 4 root 2 meters per second. Quite a problem, I would say, but we have just approached it logically, systematically, and we have come to the final conclusion. Think about it. So a lot of things over here. Acceleration was not a function of time, so we converted the variables into a desirable form such that I can integrate it using something called as the chain rule, and doing some mathematical manipulations, I have found velocity as a function of x. All right, so this is how you use chain rule and integration together. So it was a very good problem. Okay, let's go ahead. So 4 root 2 meters per second. Well, this question you had to find the equation of trajectory. This was the last question, and you can see there is something I cap and something j cap. So the trick over here, this is a two-dimensional problem, but don't get scared at all. Just solve systematically everything separately. That's all. So here they have given you the x velocity is 2t square minus 1. So x velocity is 2t square minus 1, and they have also told that the y velocity is just 4t cube. Okay, so that is what they have given. That was the y velocity. Okay, so now what do we do? Guys, nothing difficult. If you integrate x velocity, you will get x coordinate. If you integrate y velocity, you will get y coordinate. You can treat both the axes independently. So whatever happens in x will give you x things, whatever happens in y will give you y things, and 3D is nothing but whatever happens in z will give you those z things out there. So let's start. So the x coordinate will be integral vx dt. So this will be integral of 2t square minus 1 dt, and let's do this. So 2 integration of t square. I'm just skipping a step. I hope by now you have understood how to integrate this by opening the brackets and taking the constants out, and the terms should be separated when plus and minus is there. So let's do this. Okay, so t square integration, what is it? It is t cube by 3 minus integral of dt. You should know it by now. It is just t, guys, and plus of course one constant. Well, I need to get rid of that constant. So let's see. Find the coordinates if initial velocity is 0. Also find the equation of trajectory. Okay, if something else given, initial velocity is 0. I think they should have given what is the initial position. Since initial position is not given, I cannot actually find C1. I think that was the missing information out here, or I think that was the correction out here. This should not have been initial velocity. This should have been initial position. So that is the one correction, guys. Please take note of that. I think it should have been initial position. All right. Okay. Now coming over here. So if initial position is 0, that means at time 0 x is 0. So just put 0 and 0. So C1 is just 0. Therefore x coordinate will be, what is this, 2t cube by 3 was there. So 2 by 3 t cube minus t. So that is your x coordinate. Okay. Similarly, we can find the y coordinate. So the y coordinate is integral velocity in the y-axis dt. Nothing great. So let's do that. So what is integration of vy dt? So here it is. Let's substitute. So integral 4 t cube dt. 4 is going to come outside. Integration of t cube will be t raised to 4 divided by 4 and plus some constant. So 4 goes, it will become just t raised to 4 plus c2. And I have to find that c2, guys, but it is given initial position is 0 or it is at origin. So that tells me 0 is equal to 0 plus c2. Therefore c2 is 0. Therefore y is just t raised to 4. That is your y coordinate. So we have found out the x and y coordinates of that position of that particle in 2 dimensions. Now the last part. I hope this is clear, guys. It's just independent integration in the x and the y-axis. There is nothing special. So even if you get a 3D problem now, you will be able to do it. All right. Now, what is the meaning of trajectory? Trajectory means an equation which does not contain time. So how do we eliminate time from both these equations? Very easy. Since y is t raised to 4, think about it. 4th root of y, right, is equal to t. Correct? Taking 4th root. Now use that over here. That tells me, think about it. X will be equal to 2/3 t raised to 3. Now what is t? T is 4th root of y, right? So it is 4th root of y whole cube minus t. What is t? 4th root of y. So just simplify it little bit. You can't do much. So it will be 2/3 of y raised to 3 by 4 minus y raised to 1 by 4. That's it. You cannot do anything further beyond this. That's the answer. An equation which does not contain time is called as the equation of trajectory. Equation of trajectory can be anything. For projectile, it was x tan theta minus half gx square by u square cos square theta. Now that was projectile. This is some other equation for some other particle doing some other random nonsensical thing. Doesn't matter. But this is the equation. This is the, if you tell me, oh, this is the y coordinate, you can immediately tell me what is the x coordinate. That's what this tells me. Okay, so that's how you find the equation of trajectory of any given problem. All right. So that was the answer, and we have discussed that. And remember, guys, tonight we are going to start with Newton's laws and free body diagram. Believe me, you might think that Newton's laws is easy, but I'm going to put forward some amazing questions in front of you, which will definitely open up your mind on how to solve pulley problems, string problems, tensions, etc., non-inertial pseudo forces, etc., in the next class, and then frictional force. So this is the schedule for this week. And to get all the extracts, to get all the assignments, to get all the notes, to get everything, the notifications, when is the next session, special lectures, etc., do not forget that we have our own Telegram group. You can subscribe to that, install the Telegram app, and please go and follow us over there. All right. And if you enjoyed today's lecture, guys, please do not forget to like it. I'll be very happy to see this like out there, and please share this with more of your friends. Make this channel popular, guys. We are going up very good. We have become a very, very strong family now. And all those new users, please do not forget to subscribe, or else you'll be missing out on the next session. All right. YouTube won't suggest you this lecture unless you like and subscribe it. So do not forget to do that. All right. So that was it for today, guys. That's all. And our kinematics is done. So we are going to enter the next part, which is dynamics. Okay. See you guys tonight at 7 p.m. sharp. Do not forget to join in. exactly at 7 p.m. Okay, bye bye, take care, see you.